questions. Okay, so from the previous years, ECE students take the final exams. I mean, just question and answers, no for multiple choice. But from now, ECE 2025, okay, the final exams will be multiple choice exam questions, and about 33 to 35 questions. Okay, yeah, and the time length, it depends, 90 minutes or 120 minutes. Okay, it depends on my decision when we finish the course. Okay, yeah, sometimes 90 minutes, sometimes 120 minutes. It depends on the difficult level of final exam questions. Okay. So if we follow the VGU's exam regulation, okay, we totally will have 12 classes. Okay, so you can cut class maximum 3 classes. Okay, yeah. So if you cut 4 classes, that means you cannot join the final exam. Okay, and you will fail this course. Okay, remember that if you have some problem with your family or health problem, yeah, you can cut class. But remember, the maximum number is 3. Okay. So for now, we go to lecture 0. We have the introduction of this course. So can you see my slides? Okay, good. Again, if you have some problem with internet connections, okay, just tell me. Now we come to lecture 0. That means the introduction of this course. Okay. We discuss about learning outcomes of this course. Okay. So I hope when you finish this course, you can get some basic knowledge about physics 1. And again, Mr. Tung, yeah, please help me to make a recording of the lectures. Okay. So yeah, you have the knowledge of conversion unit. Okay, so that means you understand the units of important parameters, for example, mass, length, times, velocity, acceleration, yeah, and so on. Okay, we have the ability to apply a principle of Newton. Okay, Newton laws to predict and account for simple phenomena models. Okay, so for actually, so we have 3 Newton, right, law. Okay, so how can we apply these law into the physical models? Okay, yeah, we have different motions. Okay, we have a straight motion or straight motion or a circular motion. Okay, straight motion or a circular motion. Yeah, and it depends on different motions. We should apply the Newton laws, okay, yeah, into the physical model, yeah, to solve the problem. Okay, so next. According to the contents of the course, we have maximum 8 lectures or 9 lectures, I forgot. Okay, but I think we just study the first 6 lectures. That's okay. Okay, and of course we have physics 2, and physics 2 will follow the content of physics 1. Okay, so for lecture 1, this is the easiest lectures. Okay, we discuss about the unit, these physical quantities, and the vectors. Okay. Mm. For example, we have 3 fundamental quantities of physics. Okay, and what they are. Okay, so if you come to lecture 1, you can understand 3 fundamental quantities of physics. We should understand what is the difference between scalar and vectors. Okay, we have scalar product, we have a vector product. Okay, so what is the key difference between scalars and vectors? Okay, how to add and subtract vectors graphically. Okay, so for what the components of the vector are, so that means every vector, for example, we have vector A, we can analyze vector A to become the vector AX and the vector AY. Okay, or vector AZ. Okay, it depends on the different coordinates. Okay, so the question is how many components of a vector we need. Okay, maybe we only need 2 components of the vector, or maybe 3 or more. Okay, it depends on the physical model. Okay, so what the unit vector are. Okay, how to use them with component to describe vectors. Okay, so this is the constant of lecture 1, and later on we will study lecture 1. Okay, so next, lecture 2, we will discuss about particle kinematics, and we focus on straight line. Okay, sometimes we say straight line, or you can say straight motion. Okay, that's okay. And yeah, of course, we know for every motion we need to consider distance, speed, velocity, and acceleration. Okay, so for the velocity, we have average velocities, we have instantaneous velocities, average acceleration, and instantaneous acceleration. Okay, yeah. So let me summarize for you. So every motion, right? We have distance, we have speed, okay? We have displacement, okay? Later on, we will discuss what is distance, what is displacement, okay? We have speed, we have velocity, okay? For velocity, we have average velocity, okay? Then we have instantaneous velocity. And similarly, we have acceleration. Well, acceleration, we have average acceleration. And so we have instantaneous acceleration. Okay. How to explain the graphs of position versus times. Okay, normally is position. We have the symbol of x. Okay, so velocity. We have the symbol v, and for acceleration, we have the symbol is a. Okay, of course they are on vectors. Okay, yeah. So how can we draw the curve of x versus times? Okay, or velocities versus time, or acceleration versus times. Okay, this is the nonlinear or linear or constant. Okay, so we have three cases, right? Okay, so if you draw the position versus times, so this is nonlinear, number one, right? This is nonlinear curve, or this is linear curve, or this is constant curve. It depends. Yeah, it depends on the random motion of the object. Okay, sometimes they are in non-linear relationship, sometimes a linear relationship, or sometimes constant relationship. Okay, so we will go details from lecture 2. Okay, so how to solve problem, okay, containing a straight line motion with constant acceleration. Okay, and if the acceleration is not constant, what will we do? How to analyze the straight line motion? Okay, so lecture 2 is the important lectures for the course of physics 1. Okay, then uh, also lecture 2, but now we consider the motion in 2 or 3 dimensions. Okay, so if we come back for this lectures, lecture 2 part 1, okay, we only have straight line motion. Okay, straight line motion mean 1 dimension. So if we have 2 or 3 dimensions, how to analyze the motion of the object? Okay, so here this is lecture 2, part 2 and part 3. Okay, so how to represent the position of a body in 2 or 3 dimensions. For example, if we have xy coordinate, so we have 2 dimensions, right? Yeah, 2 dimensions. Okay, we say is xy coordinate. Yeah, so if we have 3 dimensions, sometimes we say 3 dims, dim in dimension. We have x, y, z. So we have the coordinate like this. This one is x, this one is y, and this one is z. Okay, or sometimes you say this is x. Okay, this is y, and this one is z. Okay, yeah. So if we have 3 axes, x axis, y axis, and the z axis, okay, we have 3 dimensions. Okay, so it depends on the physical models. Okay, we have 2 dimensions, x, y, or we have 3 dimensions, x, y, z. Okay, and how to determine the velocity of a body, how to find the vector acceleration, okay, and so on. So this is the content of lecture 2, back 3, okay, or back 2 and back 3. Okay, and then we come to lecture 3. We discuss about force and motion for particle dynamics. Okay, so first of all, for lecture 3, you should understand the concept of the force. Of course, everybody knows the symbol of force, right? Force is F. F means force because we use the first letter of force. So this is F. F is force. Okay. So force is also the vectors. Okay. So if we apply 2 dimension, okay. So force is Fx plus Fy, right? Okay. So what is the concept of force? Why we use force when we analyze the motions of the object? Okay. And then what is the significance of the net force? Okay, sometimes we say net force, sometimes we say total force. Okay, they're the same. Okay, and the relationship among the net force, the object's mass, and its acceleration. Okay, so for lecture 3 is also important for this course. Lecture 4. we study further application of Newton's laws. Of course, we have 3 Newton laws. Okay, the Newton's first law, Newton's second law, and Newton's third law. Okay, so for lecture 4, we have many applications. We have many examples. You need to apply the Newton's law. Okay, yeah. So, for example, how to solve problems containing the force that are on the body moving along a circular path. Okay, yeah, we have straight motions, we have circular motion. Okay. And for lecture 4, we should understand different types of friction force. We have static friction, we have kinetic friction, we have rolling frictions, and fluid resistance. But normally we skip this one. Okay, we skip this one. We just focus on what is static frictions, what is kinetic frictions. Lecture 5. Okay, we discuss about work, power, and energies. You know, what is work? Okay, work. So we use the symbol of W. Okay, capital W. We have power, and we have energies. Okay, so we come back a little bit. Okay, now we should have the comparisons between mechanical parameter and electrical parameters. Okay. Yeah. So for physics 1, we consider many mechanical parameters, but for physics 2, we will focus on the electrical parameters. Of course, they are very different. For example, when we talk about speed, this is mechanical parameter. We talk about velocity. Okay, we talk about acceleration. Yeah, we talk about for distance. Okay, yeah. So when we mention about speed, velocity, acceleration, distance, they are all mechanical speed. Sorry, mechanical parameters. Mechanical speed, mechanical velocity, mechanical accelerations, mechanical distance. Yeah. So when we talk about electrical frequencies, we have frequencies. Yeah, frequencies. Okay. Sure, but you should remember in these in the same physical models, okay, we have the relationship between speed and frequency. You know, speed is mechanical parameter, frequency is electrical parameters. Okay, so how can we convert? How can we convert between the mechanical parameter to electrical parameter and vice versa? Okay, later on I will tell you. Okay, so for velocity, so for electrical parameter, we have angular frequencies. Angular frequency. This is omega. This is F. Okay, omega is angular frequencies. Of course, we have a current, right? We have voltage. Okay, yeah, current I and the voltage EV. Okay, vector. Yeah. So now we have some parameters. Sometimes they are mechanical parameters. Sometimes they are electrical parameter. For example, we talk about power. Power. Okay, we have mechanical power. Mechanical power. We have electrical power. So it depends on the characteristics of physical models. Okay, if the physical model is electrical models, we consider the electrical power. Okay, if a physical model is mechanical models, we consider mechanical power. Okay, so when we talk about the power, we have mechanical power, we have electrical power. Okay, when we talk about energies, we have mechanical energies, we have electrical energy. Okay, yeah, we talk about work. Okay, we have mechanical work, we have electrical work. Yeah, so that's the reason we study lecture 5. Okay, and we focus on powers, energies, and work. Okay, mechanical, they are mechanical parameters. So this is physics 1. So here we study physics 2, and physics 1 I cover this course. So physics 2 Dr. Hiển will cover this course. Okay, yeah, because I don't have enough time to teach physics 1 and also physics 2. Okay, so physics 1, when we talk about the power, we talk about energies, we talk about the work. Okay, you should think about mechanical parameters, okay, more than the electrical parameters. Okay, now come back the lectures. Now we also study the definition of the kinetic energies. We have potential energies, we have gravitational energies. Yeah, we have many kinds of energy, elastic energies. So for the lecture 5, we also study different kinds of energies. Okay, different kind of energies. Okay. Lecture 6, we will discuss about potential energies and energies conservation. Yeah. We study the non-isolated systems, the isolated systems. So what are conservatives and the non-conservative force? Okay, force. What is the relationship between the conservative force and potential energy? Okay, and what are the energy diagrams and equilibrium of systems? Okay, yeah. So for lecture 6, we have two, 1 or 2 classes to finish lecture 6. So for lecture 7, this one for your reference. Okay, we will skip lectures 7. Okay, lecture 7 we discuss momentum and collisions, but we skip lecture 7. And yeah, of course, we study lecture 8. Okay, lecture 8 we study rotational motion. Okay, sometimes we say rotational motion, or sometimes we say it's circular motion. Okay, so for rotational motions, we also study angular position, angular velocities, angular accelerations. Okay, so what are rotational kinematics, angular and linear quantities? Okay, rotational kinetic energies, yeah, and work, power, and energy is rotational motion. Okay, so this is the contents of lecture 8. So for lecture 9, for your reference, we skip it. Okay, lecture 10, skip it. Okay, of course you can read textbooks to understand more about oscillations and also angular momentums. Okay, so we finished. So totally we study. I hope we can finish 7 lectures, right? And we skip lectures 6, lecture 8, and lecture 9. Sorry, lecture 7, right? Lecture 7, lecture 9, and lecture 10. Sorry. Okay. Yeah, so we will skip the lecture 7, lecture 9, and lecture 10. This is for your reference. Okay. So any questions about a list of lectures for this course? Okay, no questions? Continue. We discuss about learning activities. Okay, this one is very important, you know. No, now attendance 10%. Okay, so how can I check your attendance? Sometimes TA teaching assistant will check attendance. Sometimes I will give you 15 or 30 minutes quick text. Okay, so if you do or you complete the quick text, that means you get attendance. Okay, individual assignment 10%. You know, every student should do the homework. Okay, for himself or herself. Okay, of course, you can discuss with the other students. Okay, you discuss about the results, you discuss about the method, how to do the homework. Okay, but you need to answer. That means you need to write. Okay, to do the homework for yourself. Okay, you can discuss about the ideas. You discuss about the results, discuss about the questions, but you do the homework for yourself. That means you cannot copy the answers from the other student. Okay, no, you will get uh, plagiarism, you know, plagiarism. Vietnamese means đạo văn. Okay, so try to do the homework for yourself. Okay, you cannot copy and pass. Okay, the answer from the other students. Okay, because if you get plagiarism, so you will fail this course immediately. Okay, remember that. So for final exams, 100%. Okay, this is a closed book exam. Remember, this is a closed book exam. Okay, however, the students are allowed to only use one. Okay, one A4 double side digit. Okay, so we have a digit A4, and then you can write anything you want. Okay, into the digit. Okay, you cannot carry book. You cannot carry your laptop, your tablet into the final exam room. No. Okay, you just carry one A4 size, A4 size double side digit. And remember that the digit is written by hand. Is written by hand. Okay, you cannot use my slides and then use insert into the A4 digit and bring out. No. Okay, remember that your digit is written by hand. Okay, yeah. Yeah, so for totally you have 10% for attendance, 10% for homework, and 100% for final exams. Okay, so for totally you have right, totally you have 120%, right? 120%. So if you would like to buy this course, you just get at least 50% over 120%, you will match the cost. Okay, now we talk about the lab activities. Of course, we study the theory, and then we also study the experiment in the lab. And Mr. Tan, okay, who is a lab engineer, will teach you, will guide you how to do the lab experiment. So we have 3 experiments, 1, 2, 3. So for example, experiment 1, we understand how to determine the gravity, blah, blah, blah. Okay, experiment 2, we determine the moment of inertia. Okay, and experiment 3, we determine the wavelength of a laser beam. Okay, blah, blah, blah. Yeah. Okay, so totally we have 3 experiments, and remember that you need to pass the lab, okay, before you take the final exams. Okay, and now we talk about the pass condition. Yeah, here 2 requirement. Okay, you must get at least 50 over 120%. You will pass this course. Okay, of course you must pass. You must also pass all lab experiments. Okay, so for the result of the lab activities, we just get pass or fail. Okay, no score. Okay, so if you pass the lab experiment, you can continue to take the final exams. Okay, for the final exam, we have score. Okay, yeah, and you need to get at least 50% over 120%. Okay, to buy this course. Reference, yeah, we have 3 textbooks. Okay, textbook 1, textbook 2, and textbook 3. Okay, so if you have more time, you can read on textbook. But if you don't have more times, you just read the first textbook. That's okay. Okay, yeah, physics for scientists and engineers with modern physics. Okay, so for the first textbooks is, I think it is a little bit easy for you to understand. Okay, so and then if you have more time, you study this textbook. Okay, and then you would like to read more. Okay, you can study. You can read this textbook. Okay, so I make the ranking for you. The first one, textbook 1. The second one, textbook 3, and the first one, textbook 2. Okay, we make the easiest book. Okay, you can understand, and then this is medium. Okay, so that means sometimes the content are difficult for you to understand. Okay, so step by step, you need to read textbook 1 first to get the basic knowledge, to get familiar with the content of physics 1. Okay, then you move to textbook 2 if you have more time, and textbook 3. So if you don't have more time, just textbook 1, that's enough. Okay, is it clear? Any questions? So if you have any questions, okay, just tell me. Okay, don't need to raise your hands, just tell me and I will answer to you. Any questions, please, so far? Okay, yeah, and I also uploaded these 3 textbooks, okay, into the VGU Moodle platform. Okay, so you can download them and read the textbooks for yourself, maybe at home or at the libraries. Okay, depends on you. So we finish lectures 0. Okay. So now we come to lecture 1. Okay. So from yes. Lecture 1. Okay. Okay, so for lecture 1, we will discuss about units, physical quantities, and vectors. And they are the learning outcomes of lecture 1. I also introduced to you before. You need to understand 3 fundamental quantities. what is the difference between the scalars and vectors? Okay, what are the components of the vectors? Okay, and what are the unit vectors? Okay, yeah. And when we finish lecture 1, we have the knowledge of 3 fundamental quantities, scalars, vectors, the components of the vectors, blah, blah, blah. Okay, yeah. So lecture 1 is very easy. Okay, I think all of you understand clearly the content of lecture 1. Okay, so we have 6 sections. Okay, so yeah, section 1, physics and the scientific methods, unit vectors. Okay, we have the comparisons between vectors and scalar quantities, vector additions, vector subtractions, yeah, in polar form, vector multiplication. Okay. Now we come to the contents of lecture 1. Look. Here we have the general ideas of the motion, right? Yeah. So here this is the motion of the boat, right? Okay. Like this. Yes. So this one, of course, not straight motion. Not straight motion, right? Because if we consider this origins, this is y and this one is x. Okay. Yeah. So this is the motion in 2 dimensions, x and y. Okay. Yeah. So you need some basic mathematical principle to describe the motion of the board. Okay. Just the concept of the motions. For example, here we have a scale. Yeah. So for now, this is the motion of the scale. Okay. Yeah. So you will learn to make the motion diagram. Okay. For example, here at the beginning, this is T0. It's a T0. And after some time, T1, it will be here. T2, T3, okay, T4, T5, T6, T7. Okay. So if we consider if you consider the position, okay, position, and this one is x, this one is y. Okay, so here this is position and this one is times. Okay, yeah. And yeah, first of all, at the T1, T0, T0, he will be here. Okay, so you get x0, x0. Okay, at the T0, and then the T1, it will be here. So you get x1. Okay, so x1 is higher than x0, right? This is x0. You know, remember this one is x. Okay, so yeah, so you get x1 is here after t1. So at the beginning he will be here, and after some time he will be here. Okay, x1. So t2. Okay, at the t2 he will be here, and we know x2 higher than x1 higher than x0. Okay, this is x2 maybe here. Okay, so yeah, so x3. Okay, x3 is maybe the big at the big. Okay, so this is x3. So this is t3, and then you can get x3. Okay, this is x3. So t4, you know, t4 we have x4 is lower than x2 and x3, but higher than x0 and x1. So x4 will be here. Okay. So x4 will be here, right? x4. Because x4 is less than x2 and x3, but higher than x0 and x1. So this is x4. Okay, you can get to t4. Okay, so x5. Okay, x5 at t5, t mean time, you know. So x5 is lower than x1, x2, and x3. So here, this is t5, and then you can guess x5. Okay, and x6 and x7, of course, less than x0. So maybe here is x6, and this is t7, this is x7. Okay, so if we connect here, you can get x0 to x1, x1 to x2, x2 to x3, and x2, blah, 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 blah. Okay, you can get the motion. Okay, follow what? Follow the x-axis. Okay, follow the x-axis. Remember that. Okay, and similarly, if we analyze his motion with y-axis, okay, we can have this is y and this one is times, okay, and blah blah blah. Okay, so now I introduce to you x versus times, right? X is position, x-axis position. Okay, just give you the idea. If we have the xy coordinate, okay, xy coordinate here, yeah, you can indicate x versus times or y versus times. Okay, why we need x and y? Because this one is not straight motion, right? Yeah, if we follow the high school physics, okay, this one, of course, this one is not straight line motion like this. Okay, so if we mention about straight line motion, this is x-axis or this is y-axis, right? This is straight motion. But now, you know, this one is non-linear motion. So we say xy coordinates. Okay, so we can indicate x versus times and y versus times, and then we combine x versus times and y versus time. You can get his motions versus times. Okay, yeah. So this is the general ideas of lecture 1. Any question, please? So far, any questions? So remember that if you don't understand, you can ask me immediately. Okay, interrupt me and ask me to explain again. Otherwise, the lectures will start from 9 a.m. and finish at 11:30 a.m. So you also have the other 30 minutes from 11:30 to 12 p.m. Okay, to ask TA, and TAs will answer to you. Okay. Yeah, we have two TAs, Mr. Tong and Mr. Tan. They will help you to study very well with this course. Okay, so now, yeah, similarly, we have this bit. Okay, we have this bit value. Okay, yeah. And the units of speed is miles per hour or kilometer per hour. Okay, you will learn the unit used in science, and you will learn to convert between different units. So for in the high schools, a reverse course means at the high schools. Okay, you also study this knowledge of trigonometry. right? Okay. So we have upper side, we have hypotenuse, we have adjacent, right? So of course this one is 90 degree. Okay, yeah. So we can determine the theta, right? Theta. For example, here. So if we would like to calculate sine theta, so sine theta is upper side over O over X, O, X, and A, right? A, X, and O. Okay. Or we can calculate cosine theta. Cosine theta is over X. Okay. And we can calculate tan theta. Tan theta is sine theta over cosine theta. You get O over X. Okay, divided by cosine theta, that means S over A. Okay, so finally you get O over A. So we can get tan theta is upper side of adjacent. Okay, and then we also, for example, this one is phi, right? Okay, so you can get sine phi, tan phi is also for cosine phi. Okay, yeah, yeah. Of course, we know what is this principle of trigonometry. Okay, so next, for example, okay. What is the length of hypotenuse of this triangle? Here, this is X. Okay. So we have this one is 8, this one is 6 centimeters. Okay, and you need to choose this is A, B, C, D, F. Okay. Yeah. So for we have many ways. For example, if we apply this knowledge, okay, so you can calculate the phase angle first. Of course, we can apply the log cosine or um, log size, okay, cosine law, okay, yeah, but later on. Now we try to apply the knowledge from this slide, okay. So we have this one is theta, okay. So you can calculate tan theta. So tan theta is 6 over 8, right? So after that, you can get theta, right? So theta is tan to the power of minus 1, 6 over 8. You get how many? Tan, sorry, tan 6 over 8. You get nearly 36.9 here. Here, 36.9. Okay, this is 90 degree. Okay, then you can get the others. Okay, so for the total angles is 180 minus 90 minus 36.9. So you get here is 53.1. Okay, yeah. So if we have theta here, you can get x, right? For example, sine theta. Sine theta is, yeah, sine theta 6 over x. 6 over x. So you can get x is 6 times sine 36.9. Okay, sine 36.9 times 6. Eh, over, sorry, over. So we have 6 over psi 36.9. Okay, so you get 9.99 is the tenth. Okay, so the answer is tenth. Okay, but if we apply the knowledge from this slide, it's not good. It's not good. Why? Because we can apply cosine law or sine law for the high school, right? The high school physics to get H, yeah, maybe faster. Okay. So for later on, we will review for what is cosine law and what is sine law. Okay, of course, yeah, you know, right? Okay. So yeah, this something like that. Okay, for lecture 1, we review for the principle of trigonometry. Okay, now we have first of all we have the general ideas. What is the difference between the speed and velocity? Okay, so now the answers. The velocity contains the information about the direction of the motion, while speed does not. Okay, so according to this one, we think about the vector. You know, for example, we have vector A. Okay, when we talk about the vectors, we have magnitude, right, and angle. Okay, so remember, when we indicate the vectors, okay, we should think about the coordinate, you know, coordinate. So if we don't have coordinate, you cannot represent the vectors. Please remember that. So if we have vector A, for example, like this, okay, yeah, so we have the magnitude. So we have the magnitude. This is a magnitude, right? Magnitude. And if we move x-axis to be here and the y-axis will be here, so you get the angle here. Okay, this is the angle. Yeah. So remember that when we determine the angle, we compare the vector A with x-axis. So sometimes we say x-axis is reference axis. Okay, so any angle of the vectors we need to compare with the x-axis. For example, if we have vector c like this, okay, so that means now we have the phase angle of vector c here, okay, phi c, this is phi I. Okay, yeah, so again, when we consider the phase angle, okay, we need to compare the direction of the vectors with x-axis. Okay, we compare the direction of vector c with x-axis, you can get phi c. Okay, so this is the tip for you. Okay, so now come back to the answers. Look, so when we talk about the velocities, you should have the information of the direction. Okay, backward direction, forward direction, upward direction, downward direction. But actually, we must consider the direction when we use velocity. So the speed, no. So that means the speed is the magnitude of the velocity. Okay, the speed is the magnitude of the velocity because we don't care about direction. Okay, so if we don't care about direction, that means we don't care about angle. Angle means direction. So if we don't care about direction, so the speed is the magnitude of velocities. Okay. Example. Here, the quantities. This is the quantities. Has how many significant figures? So if we have 2.67 times 10 to the power of 3, so that means you get 2670, right? Yeah, okay, so here we have 3. Why we have 3? Because here we get 10 to the power of 3. So I can analyze this is 2.670, right? 2.670 times 10 to the power of 3. Okay, so that means we need 3 figures after the decimal point. 3 figures after the decimal point. Okay, so how many significant figures do we need? 3. Okay, for example, so if we have if we have 2.60 and 2.671 times 10 to the power of 3, 10 to the power of 3. This one is more precisely. Okay, more precisely. Why? Because if we take the 2.671 times 10 to the power of 3, you get 2.671. But here, this is 0, so you get 2.670. Okay, so this one, look. When we compare these numbers and this number, okay, we just focus on 3 significant figures, 670 or 671. So this is 3. Okay. Yeah. So now, if we have 2.64 times 10 to the power of 4, okay, so that means you get what? 2.6700 times 10 to the power of 4. So that means the answer is 4, because we need 4 significant figures after the decimal point. Okay, this is decimal point, right? So we have 1, 2, 3, 4. So actually, if we have 4 significant figure, maybe we have the 2.678985, something like that, times 10 to the power of 4. So you get 2.6785. So we need at least 4 significant figures. Okay. Yeah. You will study another course, electrical measurement and instrumentations. Okay, that's by Dr. Hiu. He will tell you what's the meanings of significant figures. Okay, so please answer to me the correct SI units for distance and mass. Okay, 30 seconds. Think about the answers. Okay, what is the SI? SI unit of distance. So the answer is.
Answer is meter.
Okay, yeah, we have C's, meter, and RAMs. Congratulations, you failed this course. Okay, you failed this course. Why? Because for SI units, the distance unit is meter, but the mass unit is kilogram, not RAM. Okay, you are wrong. Congratulations, you failed this course. Okay, that is the reason you study physics 1, right? Okay. So sometimes the physical model must be using SI unit for many parameters. For example, we have times. Okay, this is seconds. Distance. I mean SI units. Distance is meter. Correct. You are correct. Meter. Correct. But for mass, we should use kilogram, not RAM. Okay. So don't worry. We have the lectures to help you review the SI unit. Of course, when we analyze the problem, when we solve the questions, it's up to you. You can use RAM, kilogram, meter, kilometers, nanometers, centimeters, any units you want. But when we mention about SI units, we should have meters and kilogram. So the question is, why we use SI unit, right? Why? Yeah, I mentioned before, so when we analyze the physical model, we solve the questions. You can use any units you want, meter, kilometer, but we use SI unit for standard measurement. For example, when we design any new object, for example, you design the new motors, you design the new IC chip, okay, you design any object, new object, you need to take that object into the standard lab, okay, standard lab, and then you do some measurement, okay, you measurement distance, measurement weight, measurement mass, measurement every parameter you want. So you need to follow SI unit. You need to follow SI unit, because if you don't follow SI unit, many people will don't believe your new object, your new product, okay. So when we design any product, okay, to make commercialization, okay, to make the business, you need to use SI unit when you do any measurement, okay. It's clear for you? Okay, yeah. When we calculate, you can use any unit, meter, kilometer, nanometer, centimeter. But if you would like to standardize the products, you need to make the business of the product, you need to make more standards, more general. You need to use SI units in the lab, in the measurement lab. Okay, so and then many people, many countries will believe your new product. Okay, so next questions. Okay, yeah. So think about the answers. If Sam walk 100 meters to the right, then 200 meters to the left. Okay, so his net displacement vector is, okay, point to the right, point to the left, or has zero length, or cannot tell without more information. Okay, so which answer you choose? Okay, so the answer is point to the left. Very easy, you know, very easy. Why? Look, you think about this is physical model, right? This is physical model. This is physical model. So here just left and right. So that's a straight motion, right? Go to the left or roll to the right. This is right. This one is left. Okay. So maybe he stay here. He stay here. Okay. And this one like x-axis. Okay, x-axis. So first of all, he goes to the right. How many meters? 100 meters. Yeah, 100 meters. Okay, 100 meters. And then they go to the left, right? They go to the left 200 meters. So this is minus 100 meters because this one is origin. This is origin. So this is x-axis. So this is y-axis. Okay. Yes. So for now, he is coming to the left side here. Okay, left side. Yeah, so just tell you. So what's the meaning of displacement? Displacement. How about the distance? How about distance? They move. He move. Okay, so here is 100, and then from here to here 200. So totally the distance is 300 meters. Okay, 300 meters. Yeah, first of all, they come to the right, right? He comes to the right 100 meters, and then come to the left 200. So totally the distance is 300. But when we mention about displacement, you know, displacement occurs if we have x-y coordinate. So if you don't have coordinate, you don't have displacement. Okay, we just have distance. Okay, so now after come to the right 100 meters and back to the left 200 meters. So now he's here. Now he is here. Okay, he is here. Any questions so far? Yeah, as mentioned before, 361 is very easy. Okay, yeah. If you studied my class, I mean you join all my class, you join all my lectures. Okay, and if you have some problem, you can STAs. Of course, not difficult to pass this course. Okay, so velocity vectors. Velocity vector. Yeah, we mentioned before. Velocities is the vector. Okay, so if we have the vectors, we need to consider uh, magnitude and phase angle, right? Magnitude and phase angle. Okay, so the vectors, the velocity vectors point in the same directions as displacement vectors. Okay, so now come here, come back here. Now you know this is a vector displacement. Okay, sometimes we say vector R. Okay, so vector R and vector V in the same direction because he's going to the left side to go to the left side. Okay, so the answer is in the same direction as displacement vectors. Okay, now yeah, come to section 1.1. Okay, with studies physics and the scientific method. Okay, um, a lot of sentence, but I just give you some key points. Okay, when we analyze any physics models or physics processes, we need to consider, you need to observe, you need to measure the quantities. Okay, the quantities. Yeah, so what are they? We have mechanical quantities or electrical quantities. So if you understand the concept and the definition of quantities, okay, you can make the measurement, you can get the solution of a physical process. Okay, yeah. And then if we have the physical model, we think about you get mathematical statement. Okay, yeah. From the physical model, we need to understand the physical model and make the mathematical statement. For example here, we have an example like this. You know, this is the physical model, right? This is the physical model because this scale. Okay, so now yeah, now I understand the physical model and I convert physical model to mathematical model, right? This is a graphical model, x versus times, y versus times. Okay, so first of all, you need to understand the physical model first, and then you convert physical model to mathematical models. Okay, so this is the reason. This is the main meaning of this sentence. Okay, and then we need to make the test to validate the answers. Okay, okay, we make the test, we make the measurement test. Okay, we make the simulation. Okay, to validate your answers. Okay, your solution. So yeah, actually now we have four majors, not three majors. Okay, for ECE program we have energy technology majors, automation technology majors, and the information and communication technologies majors. Okay, so for now we have the new majors, right? The MSE. This is micro electronics. systems engineering. Okay. Yes. So all majors, you need to study physics 1 and 2. We need to study electric circuit or electric circuit, electronic circuit, and magnetisms. Okay. Yeah. So physics 1 and physics 2 are very important. And this is because they are the basic courses for all majors, okay, in the ECE program. Okay. Yeah, we have the new majors, microelectronic system engineering. Yes. Now, if you come to the curriculum of the ECE program, we have two courses of physics. Okay, physics 1 covered by me. Okay, me. Linear algebra covered by me. Covered by me. Okay, that's all. Okay, many years ago, for 4 years or 5 years ago, I covered this course, but now I don't have enough time. So, yeah, Dr. Hiển will cover this course. Okay, Dr. Hiển, this course. Okay, Dr. Hiển, this course. Okay, do you know Dr. Hiển? Yeah, he also teach you this course, right? It's exploring engineering. Okay, and yeah, we have many lecturers. Will cover some course of the ECE program. Okay, so when we mention about electricity, you need to study this course and this course very well. Okay, this is electric circuit and electrical measurement and instrumentation. Okay, now magnetisms. Magnetism, we have one course. This is electromagnetics. Okay, yeah. This one covered by the Dr. Udo. Okay, yeah. Okay, yeah. So now, session 1.2. We discuss about the unit. Yeah, of course, SI unit. Of course, SI unit. Okay, so we have three fundamental quantities. What are they? They are length, mass, and time. Okay, yeah. So the fundamental units of length is of length, mass, and times are meters, kilograms, and seconds, right? Yeah. So if we have length, the symbol is L, and the unit is M, mass, the unit is E, kilogram, and times, the unit is seconds. So this is the symbol, right? Representation. And this is the unit. Okay, that's all. Okay, of course, we have the temperatures. Okay, the temperature. So the unit of temperature is F, Fahrenheit, F. Okay, so look. Oh, sorry. Okay, Kevin, sorry, it's my statement. Okay, so the other standards for other quantities, for example, temperatures, this is Kelvin. And the current amperes, luminous intensities, candelas, okay, blah, blah, blah. And the voltage, this is volt, okay. So here we have the definition of length, mass, and times, but this one for your reference, okay. You just read it and you can understand the definition of length, mass, and time, okay. So for now, I just mentioned about the briefest, sorry, of the unit. Okay, so you just take a look first. Okay, here. So we have the prefix zeros, megas, kilo, centi, milli, micro, nano, pico, and now we have F. Okay, fico. F. So F this is 10 to the power of 15. Okay, yeah, sorry, just remember. So if we have a meter, right, this is the units of the length, right? So we have meter, meter, meter. So we have gigameter, megameter, yeah, kilometer, centimeter, millimeter, nanometer, picometer, picometer. Okay, yeah. So here, that's the reason here we say is the prefix of the standard unit. Okay, yeah, just let you understand. For example, we have the unit of power is watt, so we have watt, kilowatt, megawatt, gigawatt, milliwatt, okay, nanowatt, okay, something like that. Okay, but this is SI unit. Yeah. Okay. Example. Yeah, we have this example before, right? So this is the physical model. Because we would like to determine the height of this tree, right? Of this tree. Yeah, and they give us the information of the distance between her and the tree. Okay, this is 50 meters, and this is the top of the meter. Okay, yeah. Sorry, the top of the tree, right? The tree. So we can get the phase angle 25 degree. Okay. So what is the physical model? We need to determine the height levels of this tree. So we need to convert the physical model to mathematical model. Okay. So and then you can calculate x. Okay. X we apply tan theta. Tan theta is x over 50. Okay. Yeah. Theta is 25 degrees, so you get tan 25 degrees. Okay, you can get H. Okay, that's so now just a simple example to let you know how to convert physical model to mathematical models. Okay, yeah, this is mathematical models. Yeah. Okay. So of course we have physical model. Of course we have physical model. So we need to convert physical model to mathematical model. Okay. Or you can convert a physical model into geometric models, because mathematical model is general. Mathematical model, it is general. Okay, we can categorize mathematical model into four types, right? Yeah, four types. We have four types of mathematical models. Yeah, we have what? We have geometric models like this. Geometric models. We have the distance. We have the angle. Okay, distance angles. Or we have simplification models. Uh, um, analysis models and structural models. Okay, so if you follow civil engineering or architectures programs, okay, normally we convert physical model into structural models. But now you are students in the ECE program, so you need to make them familiar with geometry model, simplification model, and analysis models. Okay. Why we say simplification model? Because we ignore, we skip some insignificant parameter. Actually, we have many parameters, so we need to classify what are significant parameters, what are insignificant parameters. Okay, and then we skip insignificant parameters. Okay, yeah, so that is the reason we say simplification models. And of course, we have analysis models. Okay, what are general type of problems that we have shown before? Okay, that means we compare. Okay, we compare the physical model. Okay, whether they are compatible with the reverse model or not. Okay, yeah, so that is the reason we say analysis model. We have standard analysis model. Then we compare the difference between your physical model with the standard model. Okay. Yeah. Okay, we have 4 models, and then we have how many representations? We have 3. Okay, 3 representations. We have mental representations, pictorial and simplified pictorial representations of the physical models. Okay, yeah, just for your reference. Then we have example here. Look. This one is a physical model. Physical model. We don't have any parameter here. Okay. Now we think about, we determine the velocity. Okay. We determine the velocity of this ball. We would like to get the velocity of this ball. Okay. But when we observe the motion, this is the motion. This is the motion of the ball. So when we observe the motion, this is non-linear. So non-linear, so we think about, we use XY coordinate, x-axis, y-axis. Okay, yeah. So and then we apply this coordinate to be here. Okay, so this one is y, this one is x. Okay, yeah. So here is velocity, because the pole is going down, so the velocity should be here. Okay, so now this is x-axis, right? This is x-axis. This one is y-axis. Okay, so if you find the projections of v into vx, into x-axis, you can get vx. You find the projection of v into y, you can get vy. Okay, so that means we have v, that's the combination of 2 components, vx and vy. Okay, yeah. So again, when we analyze any vectors, you need to consider coordinates. Okay, so for example, if the pole here, so v will be good enough. V is here, right? Vector v is here. So if we translate v to be here, this is v, right? For example, this is v1. This is v1, right? And then here is vx, and here is vy. Okay, yeah. So any vectors we can analyze into x-axis components, and y-axis components. Okay, yeah. So we say this one is a simplified pictorial representation for these situations. Okay, we analyze the velocities of the pole. Okay, and then this is a graphical representation of the positions versus times. You know why? This is positions versus times. Okay, this one lies sinusoidal waveforms. Okay, yeah. So we have what we have. Mental pictorial, simplified pictorial representation. We have graphical representation, tabular tabular representations, mathematical representations. It's up to you. Okay, but normally we use 3 of them. Sometimes graphicals, sometimes tabular, sometimes mathematical representation. This is a graphical representation. Okay, that means this is the waveforms. Okay, so tabular does mean we have table, right? We have table. So we have velocity, we have x position, we have acceleration, blah blah blah. Okay, we need the table. I need the time t1, time t2, time t3, time t4. Okay, so x versus times, v velocity versus time, acceleration versus times. Okay, and then the mathematical model, that means, for example, y a is x plus b, something like that. Okay, so any physical models, okay, you can convert to mathematical model, such as graphical representation, the tabular representation, mathematical representation, so on. Okay, but normally we use 3: graphical, tabular, and mathematical representations. Okay, so from this is table. Okay, we have SI unit. Okay, SI units. For areas, this is meter square. For volume, this is meter to the power of 3. Speed, meter per seconds. Acceleration, meter per square second. Okay, square seconds. This is SI unit. Okay, yeah. Conversion units, this one for your reference. We don't have enough time, but this one for high school physics. Now we take a break, 10 minutes, and then we come back to study session 1.3. So now we have 10:34. Okay, so we take a break and we come back 10:45.